Okay guys, we are at 4.2, graphing linear equations. So we're going to continue. This whole thing is about plotting points, this section, graphing lines. So when it says a linear equation, you can see the word line is in there. So that tells you it's some kind of straight line, whether side to side, up and down, vertical, horizontal. So we're going to start here. Okay, they are going to give us a function, so I'm just going to go ahead and write the one down. 3x minus y equals 7. So they gave us this function and they asked us which ordered pair is a solution. So I'm going to write the choices down. 3, 4 is one ordered pair, and we've just done ordered pairs. 1 comma negative 4, so x of 1 and y of negative 4. 5 negative 3 is another ordered pair, and the last one is negative 1 negative 2. Alright, so one of these is an ordered pair. So hopefully you're thinking about how you would figure that out, and hopefully looking at the ordered pairs you would realize that all they want you to do is plug them in until you find. So you can start from the bottom to the top, or you can just work your way and go down and see which one works. As soon as you find it, you're done. So this is obviously A, this is B, C, D, we're going to call it like that. So let's go ahead and start with A. So x is 3 and y is 4. So we're going to plug in 3 times 3 minus 4. Does it equal 7? That's all they're asking. So if the left side equals 7, then you know that A is the correct answer. So 3 times 3 is 9. 9 minus 4 is 5. Does 5 equal 7? No, it does not. So the first one, it is not. You can cross that out. Let's try the second one. 3 times x of 1 minus y. So you've got minus here from the function, and then y is a negative 4. So that ends up being, you can think about it as a double negative. So a minus and a negative is going to make what? Hopefully you remember this turns it into a positive here. So 3 times 1 is 3. 3 plus 4 equals 7. 3 plus 4 is 7. 7 equals 7. It works. So that means B is the correct answer. So 1 negative 4 is the correct solution to that question. Which one was the ordered pair? So now we're going to go ahead and we're going to graph. So I'm going to go ahead and put some graphing paper under here. Okay, so here's some graphing paper. And it says to graph the equation, so I'm going to write it here. Negative 2x plus y equals negative 3. Okay? So this is the equation that they want us to go ahead and graph. All right, we're going to graph this. So hopefully you remember from last year that you always want to get this in what they call slope-intercept form. So that means you want to solve it for y. Okay, so hopefully this will bring back some memories. So we want to solve it for y. So I have a negative 2x, so obviously I'm going to add 2x and bring it to this side. So I'm going to cancel here, and I get y equals 2x minus 3. This is called slope-intercept form. You always want it in this form if you're going to graph an equation. All right? So to graph a line, the minimum is 2 points. Normally, I like to have 3. So this is something I'm going to introduce to you. It's the shape of a T, okay? It's a simple way to plot points. On the left side is going to be X, on the right side is going to be Y, okay? So it's called a T chart, easy to remember in the form of T. Instead of doing that big graph that we did last time from 4.1, and we plugged in and did all this, you can simply pick an x, plug it in and get your answer, and you get a y. Okay, and here, unless it tells you the domain, you can pick whatever points, but bear in mind that you want to try to make this fit. All of this is by ones, so you want it to fit in a 10 by 10. So one of the numbers I always include is I always include 0 because it's easy. That's a must, unless that doesn't work. But 99% of the time, 0 is a great one, okay? Then I normally use something negative, maybe a -2 and then a +2. So I'm putting it in order from my smallest x value to my largest x value. And I plug them in and see if it works. So just like we did last time, we're plugging in 2 times -2 minus 3. You can still do the work here, or you can use that big chart that I did last time with the x and the function in the middle, then the y. You can do that too. 2 times -2 is -4. -4 minus 3 is going to be -7. So that fits very good. -2 and -7 fit. So that's a good choice. I love 0 because it's easy. So 2 times 0, anything times 0 is 0. And then 0 minus 3 is -3. Since you're in my honors class, that one you should be able to do in your head. And the further we get along and the more practice, you'll get more and more proficient, and you won't have to show every little step at the beginning. Obviously you do as you get more proficient. I still like to see your steps in algebra, but I'm just saying things like this part of it, sometimes you don't have to plug in like for 0. You should be able to see that's a -3. So the other one is a 2, a +2. So 2 times +2 minus 3, 2 times 2 is 4, 4 minus 3 is 1. Okay, so you can see it's a function. These are your x values, and there's no repeating x's, and every x has one y. So that's how you read it. -2 and -7 are an ordered pair, so if I was going to write this out, -2, -7, 0, -3, and 2, 1. Okay, so that's called the T-chart. It's just a quicker way of squeezing it into a diagram here and not having quite as much work. So I'm going to go ahead and I'm going to graph this line. So this line goes on forever. They just haven't given us x values. So you're going to see the difference between graphing this line versus the portion of the one we graphed in 4.1. So -2 is here, and -7, that's -10, 9, 8. I'm cheating and I'm saying going this way, it's quicker. So -2 and -7 is in the third quadrant. 0, -3 is going to be along my y-axis. So I don't move in the x direction, I go down 3 in the y direction. That's the second coordinate pair. Then 2, 1. So over 2 and up 1 is right here. So those are 3 points on a graph. It helps if you have something nice and straight. I don't have my ruler, but I'll go ahead and use calculator here. Now the difference is I've put arrows at the end of my line. So why have I done that? Well, this line doesn't stop. It keeps on going. I just picked 3 numbers to show the way the line works. But I could go further. I could say -4, -1,000,000. It will just keep on going down here forever. The same here. I stopped at a positive x of 2. I could put 10. I could put 20,000. Put 10 million. So you can see when you have arrowheads on, that means you're saying the line continues on forever. It's very important. If you don't put arrowheads on your lines, that means you're saying the line stopped. And so that will make the difference between it being correct or not correct. So putting lines on the end of your arrows makes a huge difference. Okay, so look at that. That's how you graph an equation. We're going to graph two lines that are very important. One is the x-intercept, one is the y-intercept. So I'm going to go ahead and I'm going to move it over here. Okay, so I'm going to use this one and this one. So say we have, let's ignore that now, it's from the last problem. Say they want us to graph the line y equals 2. Okay, a lot of people will sometimes have a little bit of a tough time wondering how to graph this. It's actually very simple, but you have to understand it. All right, so this means that this goes through the y equals 2. Okay, so even though the y-axis goes up and down, when you graph a y equals 2, it's going to go from side to side because it's going to go through a positive 2 and it's going to look like this. Okay, remember it's got arrowheads on, so it's going in the horizontal direction on either side forever. So I'm just going to make one up. So they said graph y equals -5. Okay, so you've got to remember that's a horizontal line. So you start here, 1, 2, 3, 4, 5. So here's -5 and it is going this way. It's a horizontal line that goes on forever along here. Okay, so anytime they ask you for y equals any number, it doesn't matter if they said y equals 100, it is a horizontal line. So you have to put that together, a horizontal line. Okay, so what do you think is going to happen if now, here's another special case where they ask us to go ahead and graph x equals 7. Okay, I'm just making one up. So if y equals something goes horizontal, what do you think x equals goes? Hopefully you're thinking vertical, okay, because they can't be the same. So anytime you see an x equals a number, it means you have a vertical line going up and down. So I count here, 1, 2, 3, 4, 5, 6, 7. Okay, this is 7. So my line is going this way. So put the arrowheads up. It's going a vertical line up and down in that direction. So say now we wanted to graph x equals -4. I'm just making one up. I'll give you a second. Let's see where you would graph that. X equals -4. Okay, so hopefully you've gone 1, 2, 3, 4. And you've gone ahead and you have graphed this as x equals -4. Okay, so those are the two things. Are actually very simple, but you can't get them confused. Y equals is a horizontal line, x equals is a vertical line. So make sure you're taking notes and writing this down as I'm going along. Make sure that you are putting this in your book, your notebook, and any kind of graphing. You should have 2 notebooks. So you want to have this all down. The section 4.2, what it is when I introduce, and that you take the examples down as I'm doing them, and you're putting them in your notebook so that you have something to look at and something to go back into when you need to prepare for quizzes and tests. Okay, so we are going to move on to graph another linear function. Okay, so I'm going to get another piece of graphing paper, and here it's asking us to graph the function y equals, so I'm going to write down -1/2 x plus 4, and there's some restrictions, and the domain is x is greater than or equal to 0, then identify the range of the function. Okay, so this is your line, -1/2 x plus 4. Make sure you can see that this is a negative, and the domain is x is greater than or equal to 0. All right, So let's do the t-chart. This is the easiest. Remember, you only need 3 if you want to do 4 points, okay? So which x value do we start with? We have to, if it gives us a restriction on the domain, then we have to be able to look at this and know which is the first x value. So it says x is greater or equal. If something's equal, that means it includes. The line underneath is the equal sign. So that means it's equal to 0. So we start at 0, okay? So greater than 0 means any numbers above 0. 1, 2, 3, 4, 5, 6, 7, you can continue on forever after 0. But you cannot use any negative numbers. So the x values have to start at 0 and can be anything. So we can do them in 1s, we can do them in 2s. I could say 2, 4. The reason I want to keep even numbers is because I have a half, I have a fraction here. So the x is on top, okay? So 2 divides into even numbers easily, like 0 is easy, 2, 4, I could use 6, I could use 8. Now if I use 5 and 7, we can still work it out, but it makes it harder. You end up with decimals. So whenever you can, make math easy. Pick numbers that work out nicely. So whatever the fraction is, the denominator of the fraction, the bottom of it, look and see what numbers would 2 divide into. It divides into 2, it divides into 4, and that's why I've picked the numbers, okay? Divides into 6, it divides into 8. So those are the kind of numbers I'm going to pick. So I've decided to pick 0, 2, and 4. So again, we plug in. 0 times a negative 1/2 is 0. 0 plus 4 is 4. So when I have an x value of 0, I have a y value of 4. So 0, 4 is one ordered pair. So let's go ahead and just graph that. So I'm at 0, and then I go up 1, 2, 3, 4. So that's where my line starts. So the next one I'm going to do is 2. So watch what I was saying. So we have negative 1/2, and the x is up here. Plug in a 2 plus 4. So be careful. Always write things precisely, okay? The x is on top here, it's not in the bottom, all right? So what's 2 divided into 2? Isn't that just 1? And then 1 times negative 1 is negative 1 plus 4. So this is where if you need to a refresher on fractions, just look up on YouTube and find fractions and things like that so that you don't have any problems with that. So 4 minus 1 is 3. So 2 and 3 are another ordered pair. So I start here, I go over x of 2 and down 1, 2, 3. So it's following because it's a negative. And a negative goes downhill, okay? So I don't know how you were taught, everyone's taught different. I think about a ski slope. If it's positive or a hill, you go up the hill. So your line is going to head upwards. If you're negative, you go at the top of the hill and you're going down. So you can see, so if this is a hill, I'm going to go downwards. So this is a negative, so I can tell it's going correctly because it's going down the way it should be. And the next point should be going down further. So let's plug in 4. So negative 1/2, and then up here instead of x, I put the 4 plus 4. So it's simple division now because this is like over 1, all right? So 2 divided into 4, and then we deal with the negative here. Or you can think about as negative 2 divided into 4 is negative 2 plus 4. And another way to look at it is negative 2 plus 4 or 4 minus 2, which is easier to work out. So 4 minus 2 is 2. And then when we graph it, it should be going down further, and it should fit 1, 2, 3, 4, and then 2 right here. So it absolutely fits the way it should. Now, this line I'm going to draw is doing this. This line only has one arrowhead, and the arrowhead is here. So think about it for a second. Why don't I have an arrowhead here? All right, I've given you a few seconds to think about it. Hopefully you've said, because it can't go past 0. X started at 0. So x can't be -1, -2. We cannot go past here. So I do not put an arrowhead because we're not going further. The line starts at 0 and x of 0 right here. Okay, and it continues to go down here. So that is the difference between some of the other lines that you've graphed. Okay, so the last one is, I'm going to throw up a word problem here. And I'm going to, on this, it's easier to look and follow along here. Okay, so I'm going to read it, example 5, it's a word problem. And it says, the distance d in miles that a runner travels is given by the function d equals 6t. So don't be thrown off because it says d equals 6t. Okay? T is the time. So t is like your x. Okay? So t is the time and spent running. And the runner plans to go for a 1.5 hour run. Graph the function, identify its domain and range. Okay? So here, time, whenever you see over here, d equals 6t, whatever is on this side together here, that is going to be the domain. So t is going to be the x, and the d is going to be the range, the y. Okay, it's very easy to tell. X is always connected to a number, okay? So 6, this would be writing y equals 6x if we wrote it normally. So this t is the x value. The d is the distance, that is the y value. So let's look and see. So it says graph the function and identify its domain and range. So step 1, okay? So we're going to identify the domain and range. So we know that if you start out in a run, okay, so t is the hours, like I said, that's your x. Can you start at, this is something that comes up a lot in algebra and word problems, can you start at negative numbers for time and distance and age? So you should be able to realize that that's not going to happen. You can use negative numbers in algebra, I'm not saying that, but in word problems, a lot of times you can't use a negative number. You can't run negative amounts. You can't have time isn't negative. So the smallest that a time can be is 0. So you can see that right here. So 0 time, all right? You can't go anything less than that. And it tells you the runner plans to go for 1.5 hour run. So he's not going to run any more. So his time is at 0 and he can go up to 1.5. So they decided to do it in half-mile increments. So time is 0, then half, then 1, then 1.5 hours. Okay, so they're doing it by half an hour. So that is the most time that he's going to run for is 1.5 hours. So now when he runs that much time, we want to see how much his distance is. So he's not going to run any more than a time of an hour and a half, but we need to see how much distance he covers. So if the time hasn't begun, then it makes common sense that you haven't run anywhere. So 0 time means 0 distance, you didn't go anywhere. Then here, you have to plot the points. So you're plotting into d equals 6 times t. So if I put 0.5 or half of 6, how many miles have I ran? 3. You should be able to see that 0.5 is the same as half. Half of 6 is 3. Then after 1 hour, 1 times 6, he's now run, in 1 hour he's run 6 miles, so he's doing pretty good. Then in an hour and a half, 1.5 times 6 is going to do 9. So he's running a total of 9 miles in 1.5 hours. Okay? So then they want you to identify the domain and range. So when you graph this, you start at 0, 0. So here is the distance, and along here the x value would be the time, so you'd put time along here. And then we can see that at half an hour it was 3, at 1 he went 6 miles, and then at 1.5 he went 9. So the domain and range are going to be the same. So the domain is from here to here, from 0 to 1.5, okay? And here it is, 0, the time is between 0 and 1.5. So you can write it like that. Time is greater than or equal to 0, and 1.5 is greater than or equal to time, okay? So you can write it like this, or you can just write it out so I understand that you are saying time is between 0 and 1.5, okay, to start out with, until you get better understanding of it. Now the range is from the y values, so it starts at 0, but the range goes up to 9. So the range right here is here. So the range of the function starts at 0 and it goes up to 9. So now we have the d because that's a range. So we use d here for range and t here for domain. Okay, two different things. So again, to write something between numbers, you put the letter in the middle, and it includes 0 and it includes up to 9. So that's how you would write that. If at the beginning you're more comfortable, you can say the range is between 0 and 9. But eventually we want to get to writing that. So hopefully you understand, and you're going to practice doing these, and the more you practice, the better you're going to be. Okay guys, I will see you tomorrow.